Swayam Prabha. Digital India. Educated India.
So, friends, we are discussing about production and operations management. In this course on production and operation management, at present we are discussing a unit, that is production planning and control. This is the third session in that production planning and control. In the previous two sessions, we discussed the importance of production planning, and also we talked about material requirement planning, aggregate planning, and then we were having scheduling and sequencing. So, in this third session of scheduling and sequencing, we will talk about some more cases of scheduling and sequencing. In the previous two sessions, we talked about Johnson's rule, we talked about modified Johnson's rule, Jackson's rule, and also we have studied the graphical method of 2 jobs and n machines. So, in this particular session, present session, we will talk about assignment model, where we are going to load n machines, n jobs on m machines with the help of assignment model. Then we will talk about n jobs, one machine with due dates, and then we will talk about general issues like scheduling in service sector and so on. So, starting with the first particular model in this category, first type of situation. Here the situation is we are having n jobs, and we are having m machines. This n and m may be equal or may not be equal, n and m may be equal or may not be equal, but in this case we are taking that number of machines are equivalent to number of jobs. If number of jobs are more than number of machines, certain jobs are going to be unallotted, maybe you have to perform in the next planning period. On the other hand, if number of jobs are less than the number of machines, then certain machines are remaining to be idle, or you have to find out new jobs for those machines. And certain assumptions or certain prerequisites for n jobs m machine is all the m machines are in a position to possess any of the jobs. That means, each machine is capable to possess any job, then any of the job can be possessed on any machine. However, the time taken is different. If you see this matrix here, this is the time, possessing time. So, what we are finding is, if the job A is done on machine 1, it requires 3 units of time, maybe 3 hours. If job A is done on machine 2, it will take 7 hours. If job A is done on machine 3, it will take only 1 hour. If job A is done on machine 4, it will take 2 hours. If job A is done on machine 5, it will take 8 hours. That means, similarly on machine 1, if you look at job A is taking 3 hours, job B is taking 6 hours, job C is taking 8 hours, job D is taking 5 hours, and job E is taking 4 hours. So, like this. So, time taken is different. Objective is to assign the jobs to different machines in such a manner that the total time taken is minimum, or at cost. If it is a cost metric, then we say that the total cost is minimum. Another important requirement is only one job is assigned to one machine. It is not that I can assign half of A and half of B to let us say to machine 1. That is not possible, that is not possible. So, we have to assign only one job to the particular machine. A machine cannot receive more than one job, a job cannot be assigned to more than one machine. So, in this case we are taking 5 jobs and 5 machines. As I discussed in the introduction of scheduling and sequencing also, this type of situation arises when at the loading stage of this, that is the first step in the scheduling. We are first load the machines to different load the jobs on to different machines. So, this is the loading exercise which we are doing, just like I said that in the academic institution we are loading the various faculty members for different subjects or similarly in restaurant etc., waiters are assigned different tables. So, like that effectiveness of different waiters can be different in different areas. You may have certain areas where youngsters are there, you have certain areas where family members are there. So, each waiter may have a different kind of a effectiveness. So, our idea can be to maximize the effectiveness also in that case. If we are doing the job assignment loading in that scenario, our objective function can be to maximize the satisfaction of the customers, guests which are coming to the restaurant. Here also certain teachers may have a different effectiveness in teaching different subjects, though the teachers are in a position to teach the various subjects, but they are good in certain subjects. So, the satisfaction of the students we can have this in the matrix, and then we can see that which subject should be allocated to a particular teacher. So, that total effectiveness of a teaching learning process is maximized. So, in our case we are taking objective function as minimized time, that the time taken to complete all the 5 jobs on 5 different machines are minimum. So, that is the objective function with which we are loading the various machines for different jobs. So, we are following the assignment model, which is a optimization model. So, step 1, prepare the table of cost or time for all the jobs and all the machines. This is what is available to us. So, we have prepared the table of cost or time of all the jobs. It can be effectiveness also. There can be maximization function also in certain cases where the profit is there, and the function is a desirable function. It can be profit, it can be satisfaction, it can be effectiveness, or it can be a undesirable function or cost function or time function where objective is to minimize it. Then step 2, I am going to explain these steps with the help of this particular example. We have to create a zero opportunity cost by repeatedly subtracting the lowest cost from each row and each column. We will perform this. Then draw the minimum number of vertical and horizontal line necessary to cut all the zeros in the table. If the number of lines are equal to the order of the matrix, that is the number of rows of column, optimal solution has arrived. Otherwise, we have to optimal solution has arrived and we can move to step 5. Otherwise, we have to perform step 4 also. If we are able to cut with less than the order of the matrix, then we have to perform step 4 also. Step 4 is subtract the smallest number not covered by the line from all other uncovered numbers and add this same number to any number at the intersection of 2 lines. And with this again we will go back to step 3. And then at step 5 we will do the optimal assignments are at 0 location in the table. Start with the row or column having only 1 0. Draw lines through that row and column involved to cut other zeros in that row and column. If there is no row or column, if there is no row or column with only 1 0, then select any 1 0, and this also indicates that the problem has multiple solutions. So, I have given you this procedure, but you will be more clear once I am trying to solve this apply this assignment model to our given problem, where we are having 5 jobs, namely A, B, C and D, and we are having 5 machines, namely 1, 2, 3, 4 and 5, and we have to assign the jobs to the machines. So, this is the matrix I have taken on a blank sheet, and now let us perform the step number 1. Step number 1 is we are going to subtract the smallest number in a row from all other members of that particular row. We are going to subtract the smallest number in the row from all other members of that particular row. So, these are my jobs A, B, C, D and E. These are our machines 1, 2, 3, 4, 5. What is the smallest number in row 1? That is 1. So, if I subtract 1 from this, I will get 2 here, I will get 6 here, I will get 0 here, I will get 1 here and I will get 7 here. In the row 2, the minimum number is 2, let us subtract that. So, we will get 4, 2, 3, 1 and 0. In row C, the minimum number is 2, let us subtract that. We get 6, we get 3, we get 2, we get 0 and 4. In row D, the minimum number is 1, let us subtract that. 4, 7, 1, 2 and 0. In E the minimum number is 3. So, 1, 2, 4, 0 and 1. So, this is we have done the step 1, subtract the minimum member in a row from all the members of that row. Now, let us see the second step, where we are subtracting the minimum member in a column from all the members of that particular column. We are subtracting the minimum member in a column from all other members of that column. We are having 5 jobs A, B, C, D, E and we are having 5 machines 1, 2, 3, 4 and 5, and we can now what is the minimum number in column 1 is 1, subtract that. So, I will get 1, I will get 3, 5, 3 and 0. In the second the minimum is 2. So, I will get 4, 0, 1, 5 and 0. Okay. Then in the third we are having minimum is already 0 is there. So, no change 0, 3, 2, 1 and 4. Third is 1, 1, 0, 2, 0. Next is 7, 0, 4, 0, 1. Okay. Now, our next step is to find out the row or a column which is having only 1 0. Now, row C or before that we can check whether can I cut this with the less than 5 with less than 5 zeros 5 rows vertical or horizontal. Let us see the row which is having maximum 0, let us cut it, and then I can cut this also with one line, I can cut this also with one line, I can cut this also with one line. So, it is not possible to cut all the zeros with less than 5 lines. So, that means optimal solution has arrived. Now, I can do the assignment. Now, I can do the assignment. So, find out the row which is having only 1 0. So, this is 1. So, I can assign the job A to machine 3. Then this has 2 zeros, let us hold it. C has 1. So, let us assign this, and once I have assigned it, I cannot assign this. So, I have cut this. Now, let us see any other row which is having only 1 0. So, this is having another row which is having 1 0. So, this is also cut. Once this is cut, this row is having only 1 0. So, this is cut, and then this is the how we are able to achieve our answer. So, the answer is I should assign job A to machine 3 and my cost will be 1 unit, job B to be assigned to machine 2 and the cost will be 4. See that job B is not assigned to the minimum member, that is 2, it is assigned here, because we are looking for the total cost to be minimized. Job C to be assigned to 4 and the cost is 2. Job D is assigned to 5, machine 5, cost is 1, and job E is assigned to machine 1 and the cost is 4, and total 1 plus 4 5 2 7 8 and 12. So, 12 time unit is 12 hours is the time taken to perform all the jobs. So, that is the optimal answer we have achieved. 12 is the time which is required to perform all the 5 jobs on 5 machines. So, this is how the assignment has been carried out. We have allocated the jobs to different machines. So, that the total time taken is minimum. So, friends, we can solve it with the help of softwares also. POM QM is one software which is available, you can download also and you can feed this data. It is very easy to use and you can solve it there also. Like I have done this with the help of solver, this QM for production and operations management, and we found that our assignment is coming in the same manner. Job 1 is coming to 3, job 2 is coming to machine 2, job 3 is coming to machine 4, job 4 is coming to machine 5 and job 5 is coming to this, and the optimal answer is 12. Optimal answer is 12. The total cost is 12. So, we can solve it with the help of POM QM also with this. So, this was the assignment model, a simple, very simple model by which we can assign the jobs to the various machines in such a manner that the total effectiveness of the system is high, the total cost incurred in processing all the jobs is low. So, that is you will find large number of applications in scheduling and sequencing or in our other in service sectors and in manufacturing sectors. Lot of such a situation arises where you have to assign the jobs to different people. It can be in as a student, you may be having a, let us say a project is to be carried out by 5 students. A project is there where the 5 students are there, 5 students are there. Suppose you are doing a project, academic project, 5 students are there, of team is 5 students. You divide the total task into 5 activities. The activities can be literature, it can be data collection, development of a software, preparing report, preparing presentation. And then you are trying to see that who should perform a particular task. Though all 5 of you are competent to do any of these tasks, but still some student is more effective in data collection, some is more good in software. So, these are your team members 1, 2, 3, 4, 5, these are your team members. So, you are trying to see that who is good in academic readings and other things, who will do the literature. Again you can develop that if person 1 is doing the academic literature, he may need 15 hours, if 2 is doing, he may take 10 hours only. If he is doing, or it can be the quality of the presentation also, in terms of that also, if 3 is doing, he will take 20 hours, if 4 is doing, he is taking 16 hours, like this. So, you can work out in that manner that depending upon the effectiveness of different student to collect this, and then you can see that you can assign that which job, which particular activity should be assigned to a particular team member. So, that is the role of assignment models, and you can apply it at different situations in your own working also as a student also. In the industry, in the manufacturing and service sector, this is widely used tool in identifying which job should be assigned to which particular machine or a person or a skilled person or a professional also may be there. Now, we are coming to a very important situation where we are having n jobs and they are having the due date also. So far, we were not considering the due date, but here now we are first time we are encountering a situation where the jobs are having due dates also. So, along with the minimizing the make spend time, utilization of the machines, etc., we have to also consider here that job should be delivered by the due date, or the total lateness of the job should be as minimum as possible. So, that is the kind of situation now we are dealing with. So, in this type of scheduling problem, the due dates of the jobs are also given, the due dates of the jobs are given. The objective is, while improving the efficiency and utilization of the resources, the job lateness should also be considered. We should try to see that jobs are performed are completed within the due date, and if at all it is to be delayed, the delay should be as minimum as possible. Then the various performance measures which we are going to use here is average flow time, utilization of the production facility, average number of jobs in the system, and average job lateness. So, we will consider that how much time the job remains into the manufacturing system, and also the how much is the utilization and number of jobs in the system and average job lateness. And we will also we are having certain priority rules which we are going to examine, and then based on the performance of these priority rules, we will select the one which is giving the best answer, and the sequence of the jobs which gives the best answer, we will try to that. So, our priority rules are first come first serve. That means, if the jobs are coming in the sequence of A, B, if the jobs are coming in the sequence of A, B, C, D and E, we will follow the same sequence in the processing of the jobs. Whereas, there is a second rule which is called shortest processing time. If the processing time of this is 10 days, processing time of this is 7 days, processing time of this is 8 days, this is let us say 5 days and this is 12 days. Then according to the this is first come first serve, and if this is the processing time, then my sequence will be shorted processing time sequence will be, I will take D first, followed by B, followed by C, then A and then E. So, this is going to be the sequence if I am following a shortest processing time. You might have witnessed this particular type of practice being followed at several places. Many times in your canteen etcetera, if you are going and you say that I need only one particular item and you are having a change also with in your hand, the shopkeeper will attend you the first, even though there is a queue or there are more persons who have come prior to you, who have come who are earlier standing, but he will follow the, because that will help in reducing the crowd in the system, that will help in reducing the number of jobs in the system. So, many times this shortest processing time policy is very good in reducing the total number of jobs in the system. Then you are having earliest due date also, if these jobs are having some due date also. So, let us say they are having the due dates also. This job need to be shipped on 12th day, this job need to be shipped on 15th day, this job need to be on 20th day, this is required to be shipped on this is required to be shipped on 11th day and this is required to be shipped on 14th day. So, if the due dates are also given to me, then as per the earliest due date policy, I should prioritize the job which is need to be shipped first. That is on the 11th day D is required. So, D will get the highest priority because this has the earliest due date. Then the priority will go to A, then the priority will go to E, then B and then C. So, this is the my sequence of the jobs if my priority is earliest due date. Okay. And there may be a case where we are considering the longest processing time, because they will take more time. So, let me start them first, though it is very rarely used, but definitely in maintenance and in other activities or somewhere, sometimes we start the job which is requiring the longest time to be started first, because it will take long time. So, if we are following a longest processing time policy, then my optimal sequence will be the job which is having the longest processing time out of this, pick up the job, or it will be opposite to the shortest processing time. I can straightway write from this. So, this will be E, A, C, B and then D. Okay. So, but this is very rarely used. The most prominent which are used are first come first serve, because that is the highest rational policy, especially when you are dealing with the in a service sector, when you are dealing with the customers, first come first serve is the most rational policy. But to reduce the number of persons in the system, I can follow the shortest processing time also, and to avoid the number of delayed jobs, earliest due date also a good policy of sequencing the various jobs in a given system is a good priority rule to sequence the jobs. But obviously, we will study all the four methods here in this particular session. So, this is the example we are taking. We are taking 5 jobs, we are taking 5 jobs A, B, C, D and E, and we are having the information about them. We are having the processing time for them, and we are also having the due date for them. So, we are having processing time and due date for them, with the information is with us, and now we have to see that we will try the various sequencing rules to see that how the job should be sequenced, so that I can improve my performance. In a particular situation, machine utilization may be a high order performance measure. In certain cases, it may be the minimizing the number of tardy jobs, number of late jobs. So, depending upon that, you can pick the appropriate priority rule, or you can pick a priority rule which is good on more than higher number of performance measures. So, you can pick that particular priority rule. So, let us examine the different priority rules. So, the first priority rule which we want to examine is first come first serve. In the first come first serve, as I said, we will follow the sequence of A, B, C, D, E as it is. We are not making any change in the sequence. The order in which the jobs entered into the system, we are processing them in the same order. So, the 5 jobs are there, their processing times are there. From this, we will calculate what is the flow time, how much time this job remain in the system. So, job A, it entered at time 0, completed in 15. So, it remains 15 days in our system. Job B, the processing time is 4. After processing this, I will take this. So, it will be completed on 19th day. Job C will be completed on 30th day. Job D will be completed on 37th day, and job E will be completed on 45 days. So, the total time required to complete all the jobs is summation of the processing time, that is 45 days. So, 45 days it will take to complete all the 5 jobs. Now, let us see the due date to find out whether we are able to dispatch them before the due date, or there will be any lateness. Now, write the due dates. Due date for these jobs are given to us. Job A has a due date of 22, and job A is completed on 15th day. So, there is no lateness for this particular job, whereas job B, it is completed on 19th day, its due date is 15. So, it is delayed by 4 days. Job C is delayed by 15 days, job D is delayed by 24 days, and job E is delayed by 35 days, and the total delay is of 78 days, and total number of jobs in the system is 146. Okay. So, that is the total flow time, that is the total flow time is 146. If we add the flow time of all the jobs, that is 146. Okay. So, this is how we can calculate the average job flow time, that is 146 divided by 5, 29.2 days is the flow time, average flow time of the jobs. This you can also understand this number 146 or total flow time. The 5 jobs remain in the system for 15 days. For first 15 days, all the 5 jobs were in the system. Then first job is out, next 4 days, 4 jobs were in the system for next 4 days, 3 jobs in the system for 11 days, 2 jobs in the system for 7 days, and 1 job in the system for 8 days. So, 75, 16, 33, 14 and 8. If we total it 6, so we will get 146 days. So, you will get the logic also what is meant by average flow time. The 5 jobs in the system for 15 days, 5 jobs in the system for 15 days, 4 jobs in the system for 4 days, 3 jobs in the system for 11 days, 2 jobs in the system for 7 days, and 1 job in the system for 8 days, and together 146 days job days are there, that is the total flow time, and we are having 5 jobs. So, 20 on the average 29 days job remain in the system. Now, the average number of jobs in the system we can find out, that is the total flow time divided by total processing time. On the average 3.24 jobs remain in the system, on the average 3.24 jobs remain in the system, Average job lateness 78 is the total lateness divided by 5, 15.6 days is the average job lateness, and number of tardy jobs, number of late jobs are 4. One job we are able to complete on time, remaining 4 jobs were delayed. So, this is how we can check the performance of first come first serve priority rule for our given example. Now, let us see the second priority rule, that is the shortest processing time. Okay. In the shortest processing time, as I said, we will sequence the job in the order of the processing time. That means, job having the minimum processing time will come at the top, and the job having the highest processing time will be the last job in the sequence. So, my sequence here is, I will first take B, then I will take D, then I will take E, then C, and then A. So, that is my sequence of shortest processing time. Now, in the same manner as we calculated for first come first serve, let us calculate the flow time. So, flow time for job B is 4, job D is 11, job E is 19, job C is 30, and job A is 45. The total flow time is 109 in shortest processing time. Now, you can compare also. This time is much lower than 146 of the first come first serve. So, shortest processing time helps us in reducing the number of jobs in the system and average flow time also. Now, let us see the due date also. Due date of job B is 15. So, we are able to do it well within time. Second is 13, that also is completed. Job 3 is delayed by 9 days. Job C is delayed by 15 days, and job A is delayed by 23 days. And now, we can see the performance of this particular priority rule, that is shortest processing time. Average job flow is total flow time divided by number of jobs, that is 109 divided by 5, 21.8 days is the average flow time, which is lower than the 29.2 days of the first come first serve system. Similarly, average number of job in the system is also 2.42 jobs, which in the previous case was 3.24. In the previous case, it was 3.24, which has been reduced to 2.42. Average job lateness is also reduced, and number of tardy jobs are also reduced from 4 to 3. So, in that manner, you will find shortest processing time gives much better performance on these performance measures as compared to first come first serve. But yes, as I said, first come first serve looks more rational, more justified from the customer perspective, but from the manufacturer, from the service provider perspective, shortest processing time gives many performance measure which are superior to the first come first serve performance measures. Now, let us see the third priority rule, that is earliest due date. In the earliest due date case, we will arrange the jobs in the order of due date, okay, in the order of due date. That means, the job which is having the earliest due date 10th day, that is scheduled first. The second job which is having the next higher due date, that is arranged in this, and the job which is having the far away due date, that is arranged at the end. And in that way, our sequence turns out to be first job E, then D, then B, then C, and then A. So, this is my sequence of the jobs if I am taking the priority rule of earliest due date. So, with this rule, let us again work out. So, these are the processing times from our original data which we are having about these jobs, and now calculate the flow time. For job E, the flow time is 8, job D 15, job B 19. It is very easy, 8, then 8 plus 7 is 15, 15 plus 4 is 19, 19 plus 11 is 30, 30 plus 15 is 45, and the sum total of this column is 117. And then now we can see that how many jobs we are able to ship without any lateness. Job number 1, flow time is 8, due date is 10, we are able to do that. Job number B got delayed by 2 days, job number 3 got delayed by 4 days, job number C got delayed by 15 days, and this is delayed by 23 days, like this. And the total flow time again we can calculate in the same manner, turns out to be 23.4 days. And average number of jobs in the system, that is 2.60, and average job lateness is 8.8 days, and number of tardy jobs are 4 jobs. Okay. So, like this. So, we can see the performance of earliest due date priority rule. Now, let us see the longest processing time priority rule, LPT. So, the sequence of this job will be as per the longest processing time. The job which is having the highest processing time is coming at the top, and the job which is having the lowest processing time is at the bottom of this sequencing. So, the sequence as per the longest priority rule is longest processing time is A, followed by C, then E, then B, and then D. So, this is the sequence as per the longest processing time priority rule. And let us see the performance of this particular system. Obviously, the flow time will be higher in this case, because all the 5 jobs are waiting for 15 days, 4 jobs are waiting for 11 days, 3 jobs are for 8 days, 2 jobs are for 7 days, and 1 job is for 4 days. So, the flow time is much higher here. Due dates are given here. So, we can calculate the job lateness also, and in the same manner job 1 is not late, job 2 is late by 11 days, 3 that means E is late by 24 days, B is late by 28 days, and D is late by 30 days, and total is 93 days. From this, again let us calculate the performance. Average job flow time is 32.2 days. Average number of jobs in the system is 3.58 jobs, and average job lateness is 18.6 days, and number of tardy jobs are 4 jobs are which get delayed, which we are not able to ship by the due date. So, that is how we can see this particular priority rule. Now, let us put all these performance measures of these 4 priority rules together in one place. So, this is a summary of that. So, 4 priority rules: first come first serve, SPT, EDD, and LPT. So, 4 priority rules, and we have taken the 4 different performance measures: average job flow time, average number of jobs in the system, average job lateness, and number of tardy jobs. So, let us see from the average job flow time perspective, we found that SPT is the best. SPT is the best. Shortest processing time has the best results as far as average job flow time is concerned. There the average job flow time is 21.8 days. Okay. Now, average number of jobs in the system, obviously this is that the 2 measures are reflecting the same aspect. So, 2.42 is the average number of jobs in the system. You will find that next best is 2.6, next best is 3.24, and next is 3.54. Same is the sequence here. This is 1, then this is 2, this is 3, and this is 4. Same is the number here. You will get 1, 2, 3, and 4. So, this is how you will find that both these are surrogates for each other. If one is improving, second will also improve, or they are reflecting same thing. Now, let us see the average job lateness. Earliest due date gives the best answer in this case. Earliest due date gives the best answer in this case, and whereas number of tardy jobs is best coming in case of shortest processing time. So, like this we have seen that. So, we found that shortest processing time rule give better results on 3 performance measures. Shortest processing time rule gives good results on 3 performance measures. So, maybe for this particular type of situation, organization can adopt the shortest processing time as its priority rule. So, some of the observations from this table: no one sequencing rule excel on all the criteria. Obviously, certain criteria are good on certain priority rules are good on certain criteria. SPT does well on minimizing flow time and number of jobs in the system. We have found that they are number 1 on that. SPT moves long jobs to the end, which may result in dissatisfied customers. That is very important to see that. If you are having a bigger order that means you are getting delayed, you are having the least priority. So, which is not a very good that way a strategy from that perspective. So, we have to see that how to mix the two or three priority rules together. You may say that for certain jobs which are very small of less than a certain time duration, they will be prioritized, others will be following a first come first serve rule or some other. Similarly, the jobs which are having very small due dates, so they should be prioritized, others will not be prioritized, or you can mix these priority rules in some manner. So, that you are excelling on many performance measures and it will not dissatisfying the customers also. Customers also feel logical that what you are doing is logical, it is not partiality or it is not unfair to them. First come first rule does not do especially well or poorly on any criteria, but is perceived as a fair by customer. First come first rule is not good on any of the criteria, also it is not bad on any of the criteria. Like here, if you see that this is at number 3, on this also it is at number 3, here also it is at number 3, here also it is at number 2. So, it is neither best nor worst, but it is considered to be a rational system, a fair system by the customer. They say that in the order in which we have arrived, in the same manner we are getting the service. Earliest due date minimizes the lateness. So, average lateness is minimized by the earliest due date. So, that is a priority. If you want that job should be dispatched as per the due dates as early as per the due date, then maybe the earliest due date is a good priority rule. So, friends, this was a small about another kind of a situation where we are having multiple jobs to be performed in a system and jobs are having a tag of dispatch also, due date also. And we have studied the 4 different priority rules, that is first come first serve, shortest processing time, earliest due date and longest processing time. We checked these priority rules on 4 different performance measures, that is average job flow time, average number of jobs in the system, average job lateness or tardiness and number of late or tardy jobs in the system. So, and we have observed that no one particular priority rule is best on all the criterias, and then based on our objectives, based on the situation, we can select the priority rule which is best on that particular performance criteria. So, now we are moving into another situation, very interesting situation, where the schedule is in the cycling scheduling. We are scheduling the service employees, it can be doctors, nurses or it can be your hospital, hotel staff or something like that. So, in our situation we are 7 days week we are this is called roster also, roster of the weekly employees. They are not getting the weekly off on the same days, because the services are running 24/7. So, everyone is not getting the weekly off on Saturday and Sunday. You have to prepare a roster in a manner that they, and we have kept a condition that they should get the 2 consecutive days as the weekly off. It should not be the Monday and Friday or Tuesday and something. No, either we can give Monday, Tuesday, or we can give Tuesday, Wednesday, or we can give Wednesday, Thursday and so on, or Saturday, Sunday. So, 2 consecutive days are given as a weekly off in this particular example case which we are considering. So, objective is to meet the staffing requirement with the minimum number of workers. Objective is to meet the staffing requirement with the minimum number of workers. Schedules need to be smooth and keep personnel happy. Many techniques exist for simple algorithm to complex linear programming solutions also. We will take a very simple algorithm here which manually can be done, but this is good if you are having a small number of employees, then you can do that. The various steps in this is determine the staffing requirement on different days. You find out that on Monday how many people are required, on Tuesday how many persons are required, on Wednesday how many persons are required, Thursday, Friday, Saturday and Sunday. Find out how many number of staff people are required on different days of the week. Identify 2 consecutive days with the lowest total requirements and assign these as day off. So, we will I will give you with the help of example what it means. So, we will identify 2 consecutive days on which the requirement is minimum. Then we will make the new set of requirement after subtracting the day which we have already assigned, and apply step 2 to the new row and repeat the step 3 and 4 until all requirements have been met. So, very simple procedure. We will first have the requirements on different days, then we will find out 2 consecutive days when the requirement is minimum, and from that we will keep on continuing. Take one very simple example. Our requirement is on Monday I need 5 persons, on Tuesday I need 5 persons, Wednesday 6 persons, Thursday 5 persons, Friday 4 persons, and Saturday 3 persons and Sunday 3 persons. Okay, so, that is my requirement. So, in this these are the 2 days when the requirement is minimum, 2 consecutive days when the requirement is minimum. So, I will assign the weekly off to them. Employee 1 will have a weekly off on Saturday and Sunday. So, from this we can say that employee 1 weekly off Saturday and Sunday. Okay. Once we have assigned this, now what is left? We need 4 persons, 4 here, 5 here, 4 here, 3 here, 3 here and 3, because we are not assigned any person. Employee 1 is not assigned on Saturday and Sunday. So, still we need Saturday and Sunday 3 more employees, but here we need Monday, we need now 4 only, because employee 1 has been assigned on Monday, employee 1 has been assigned on Tuesday also. So, we need like this. Now, let us see. So, as is written there, 4 persons are required here, 4 on Tuesday, 5 on Wednesday, 4 on Thursday, 3 on Friday, 3 on Saturday and 3 on Sunday. Now, we can pick the again 2 consecutive weeks here. So, we can again pick Saturday and Sunday for them also, and then after doing that our requirement shift to 3 here, 3 here, 4 here, 3 here, 2 here, 3 here and 3 here. Now, I have to pick the minimum. Minimum is 2. So, I can pick this 2 and this 3, or I can pick these 2 also. 2 consecutive days I can pick. So, I can pick these 2 consecutive days 2 and 3, and so employee 3 has a working day. Let me clarify. Employee 3 has a weekly of on Friday and Saturday. Friday and Saturday. Okay. And then we will see that on employee 4. So, we again find out 2 consecutive days when the requirement is minimum. I can choose Monday, Tuesday, or I can choose Thursday, Friday also for him, or these are the 2 options available with me. I can pick any one. So, Thursday, Friday has been assigned to weekly off is given to employee 4. Once that is done, now I am left with employee 5. Once I have assigned employee 4, so I need 1 more person on Monday, 1 more person on Tuesday, 2 persons on Wednesday, 2 on Thursday, 2 on Friday, 2 on Saturday and 1 on Sunday. Now, I can pick these 2 consecutive days for my employee 5. Employee 5 will have a rest on Monday and Tuesday. So, Monday and Tuesday has been given rest to him. So, this number will remain as it is, this will reduce by 1. So, like this is my requirement. So, now employee 6 need to be given 2 days off. You can pick any 2 days for him, or we can pick 0 and 1, not only 2 days, 0 and 1, because I do not require any person on Sunday. Sunday already the adequate staff has been assigned. So, I can give weekly off to employee 6 on these 2 days. Okay. So, after doing this, now this will become 0, this will become 0, this will become 0, this will become 0, but still I need 1 more employee on Saturday. Still I need 1 more employee on Saturday. So, employee number 7 also required here. So, employee number 7, though he is going to work only for 1 day only, we do not have the sufficient load for him on other days. Okay. So, like this. So, 6 employees are fully assigned on all 5 days working days, whereas employee number 7 we are keeping it only for one particular day. Maybe you can have from some other department or adjustment from some other wing of the organization like that. We can also see that this situation we can anticipate here itself. If we make a total requirement, I can make a total here. What is the total requirement? 5 plus 5 10 plus 6 16 21 25 plus 6 31. So, total 31 duties are required and 6% into 5 is equal to 30, and still I am having one duty. So, I need 7th employee to be employed for 1 day. So, 6 employees to be employed for 5 days and 1 employee to be employed for 1 day. So, like this. So, you can work out that we can say that it is not possible to meet the requirements of on different days with 6 employees. We need to have one more employee on to take care on a particular day. So, this is how cyclic scheduling example can work, by which we can schedule the various employees on different days of the week. So, we can prepare a roster in this manner. Okay. A roster can be prepared in this particular manner. So, friends, these are some of the situations we have discussed, but obviously, the real life examples are even more complex, but combining these various rules, we can work out the scheduling and sequencing for a bigger size problems also, which is of m into n type, which is of m jobs into n machine type, and then there may be having different types of flows and other things also within that job shop. So, cyclic scheduling example, we have talked about Johnson's rule, modified Johnson's rule, Jackson's rule, graphical method, assignment model, and different priority rules when due dates are given to us, and cycling scheduling example. Let us see some of the scheduling guidelines for different types of production systems. We have seen in the beginning forward scheduling and backward scheduling. Forward scheduling is when we look at the dispatch dates or due dates depending upon the customer, based on that we work backward. We the last workstation is scheduled first, and based on that the previous stations are previous processes are scheduled. So, that is forward looking. In batch and job shop, where the due dates is given to us and it is make to order system, we will going for a forward looking schedule, where MRP provides the due dates to complete a particular activity, and this is more a finite capacity scheduling, where we know that the capacity of our different processes is known to us. If it is a work cells, there also MRP due dates are there, forward looking approach we can adopt, and detailed schedule done using work cell priority rule. At each work cell we can have a own local priority rules we can apply, so that due dates are met. If it is a make to order system, again we will look from the last process first, and then we will keep on scheduling, looking at the forward situation, and this is a pull technique for scheduling. Make to order is more like a pull, and where the demand is fairly constant, we can apply the pull system, Kanban system or something like that to based on the final requirement of a particular type model, we can apply the forward looking schedule. In a make to stock situation, where the demand is stable, you can produce based on the forecasting. What happens here is, in this case and the make to stock situation, it happens like this. Suppose this is your supply chain, this is let us say this is your production process, and this side is customer, and then this side is supplier. What happens in make to stock situation, and this can be based on the actual orders also, but we make a forecast and based on that we place the order on the supplier. We make a forecast and orders are placed on the supplier. The moment material is received from the supplier, we start the production. We start the production. Once this process is done, it will go to the second process, it will go to the third process, it will go to the fourth process, fifth process, and then it is coming, and then it is also going to the market also, like this. So, it is more like looking at whether the material is available or not. If the material is available, you start producing, and if the material is available, if the previous process has completed its job, you start doing the next job, you start doing the next job. So, this is how this particular type of backward looking schedule works, whereas this is more like a push system. We also call this as a push system, and these others are more like a pull system, which are forward looking. We see the customer, we see the orders from that, we see the due dates from him, and based on that we do the planning of our previous workstations. So, depending upon the situation, we can adopt forward looking schedules or backward looking schedules. In the service sector, though the situation is almost same as in the production, but certain complexities are there in service sector over and above the manufacturing sector. The processes are complex and more critical in nature. In hospital, complex scheduling system to handle complex processes. When I say complex processes, that means their flow is not known in advance. A particular patient, what type of facility he may require during the treatment, it is not known in advance. Just like if we look at the car service center vis-a-vis hospital. In the car service center, job card is created and the job is carried out accordingly, but in hospital you cannot create a job card. You do not know what type of emergency or what type, how the patient is going to respond to the various things. So, the processes are more complex and unknown in the beginning, and that is why the load on the various departments, and this is also very difficult to predict in advance. Then so the requirement of various diagnostics, various operation theatre requirement and paramedical staff is very highly variable in this particular case of hospitals. Bank use a cross trained and flexible workforce, a person who can work on several counters depending upon the workload. So, a very flexible workforce is very useful in service sectors, whether it is restaurants or banks, or if you are having a flexible workforce, you can deploy them as per the requirement, or otherwise you have to keep the part time workers, though it is very difficult to get skilled person for banking purpose as a part time worker. Then retail stores use the scheduling optimization system that tracks sales, transactions and customer traffic to create work schedules in less time and with improved customer satisfaction. So, there you have to, though on certain days you know in advance that there is going to be more footfall. So, accordingly you can keep more number of sales representatives and other persons to attend to the customers, but still based on the previous data analysis you can do the scheduling optimization for retail stores, etc. Airline must meet the complex regulations also. A particular pilot cannot fly more than a particular number of hours, and it has to take a rest also. Similarly, aircraft you cannot use it for more than a particular number of hours together, then it has to be go for a check and other things because of the security reasons. So, all these constraints are also there over and above the normal scheduling issues. 24/7 operations like police, fire, emergency services, they are even more complex to schedule. You do not know when all of a sudden there may be a requirement of many people together at a particular point of time. Or that is why you will find for these services they are having the housing quarters attached to the their police station or fire station itself. So, employees are staying there only. If it is required at odd hours, they can be called on duty. And so, and they are use the flexible workers and variable schedule. So, they do not follow a particular schedule as and when the emergency is there, as and when requirements are there, they are called and used. And so, these are some of the issues related to service sector. And many times theory of constraint is also used in scheduling. We find out which one is the bottleneck stage. rather than providing the schedules for all the processes in the sequence, we can adopt we can identify the one which is the bottleneck. Suppose this is the bottleneck, this is the constrained resource. So, we schedule it this only. The pace of the complete line is decided by that. If you look our JIT session, there we identified this as a pacemaker, and different theories, different name is given to this. It can be a bottleneck stage, it can be a pacemaker, it can be a constrained resource. In the theory of constraint, throughput is the main issue. We have to ensure a very high throughput, more number of units are processed in a given facility, and in that we will give highest priority in scheduling to the pacemaker or the constrained resource, and all other resources are, all other decisions are subordinated to this particular decision. So, we identify the constraint and develop a plan for overcoming the constraint, focus resources on accomplishing the plan. So, we focus we provide as many resources as required for this, which is possible technically, and reduce the effect of constraints by offloading work or increasing capacity. Certain activities of this can be shifted to some other places, and or we can have one more machine of this, so that this is unconstrained, but obviously then some other station will become constrained. On one successful return to step 1, once you have debottleneck this, then again you find out some other is becoming bottleneck, work out for this. So, that is how the theory of constraint works in case of scheduling. So, what we can do to decongest? Bottleneck work stations are one having least capacity or highest cycle time and limits the output and working as a constraint. Management techniques include debottlenecking the constraint or subordinating other activities, other decisions to this particular bottleneck stage. We can have cross trained employees and maintenance staff, alternate routing procedures. If this is a bottleneck stage, can I route certain jobs which are not passing through this bottleneck stage, or we can have some contractors to perform that particular operation. Moving inspection and testing prior to that, so that only good quality materials are processed through the bottleneck stage. After processing the bottleneck stage, the item should not found to be faulty or not meeting the requirement. Scheduling throughout to match bottleneck capacity. So, all the other stages are scheduled as per the bottleneck capacity. So, these are some of the aspects in this. So, to sum up, effective and efficient scheduling can be a competitive advantage for faster movements of goods through a facility. That means, better use of assets and lower cost. Additional capacity resulting from faster throughput improves the customer service through faster delivery. Good schedules result in more deliverable service. So, friends, this was a brief discussion on scheduling and sequencing under the unit production planning and control in our course on operations and production management, production and operations management. So, with this we conclude this particular unit of production planning and control. Thank you.